Okay, here we go. Number 4. A nutritionist wants to confirm her suspicion that among Americans, women tend to prefer chocolate for dessert more often than men. She decides that it will be convenient to collect data on customers of a large and popular restaurant owned by her family. The restaurant has a practice of showing the daily selection of desserts on a tray for the customers. For 500 customers selected randomly over a 1 week period, the nutritionist notes the sex of the customer and the choice of dessert. The data is summarized below. Okay, so let's take a look at this data. Well, the only one that really stands out right off the bat is this guy right here. So desserts without chocolate, female, much lower than all the others. Anyway, just kind of looking at it. Now, letter A. Identify the target and sampled populations in this experiment. Are they the same or different? Discuss how their sameness or difference will affect the conclusions drawn from this experiment. Okay, the target and sampled population. Well, they say in the question, a nutritionist wants to confirm the suspicion among Americans. Okay, women tend to prefer chocolate dessert more often than men. So our target is really, we want to determine a conclusion about Americans, okay? Everybody, men and women, and whether they like dessert, chocolate in their dessert. Now, what about the sampled population? Well, did they do a simple random sample of the entire population? Not really. It seems like it's kind of a convenient sample. She samples people from her own family restaurant. Okay, so the people that go to this particular restaurant are going to be probably a little bit different than the entire population. They have kind of a similar characteristic in the fact that they like this one restaurant. So anyway, that being the case, we can do a statistical analysis, but our results are only going to be conclusive about the people that go to this specific restaurant, not all Americans. Okay, that's kind of what you might write down, something along those lines. Let's go to letter B. Okay, so the nutritionist is considering using a chi-square test of independence to analyze the data. Why is this test inappropriate to justify her suspicions? Now, if you use a chi-square test of independence, it means basically we're testing, does it depend on whether you're a man or a woman if you order a dessert with chocolate? That's what we're testing for with a chi-square. That's not what this person is interested in. This person is interested in, do women prefer chocolate more than men? It's a one-sided test. That is not what we use for a chi-square test. Okay, that's a little bit tricky. All right, so that's the answer to letter B. It's a one-sided test. We're looking for whether women prefer chocolate more. Chi-square does not do that. All right, let's go to the next one. Okay, here we go. Which test would be more appropriate to gather evidence to support her suspicions? Can the test you named be done using this data? Justify your answer. Okay, so if you look at the chart, we wouldn't use an average or a mean. We would have to set it up as a proportion. So if we do a proportion, we would use a z-test, difference of proportions. Dude, really? That says proports. Okay, let me fix that. Proportions. Idiot. Okay, there. Z-test, difference of proportions. There. Now, this is not going to work because it's not independent. If you think about the experiment, they wheel up the dessert tray to a table and people choose desserts, right? Well, how often is it that people discuss what they're going to eat? Or, oh, I'll split that dessert with you if you get it, that kind of thing. So men and women are going to be at the same table. It's not going to be an independent choice for them. So independence is definitely going to be violated. Okay, let's go to what number 5 is next. Okay, so if you read this problem, you've got this company that installs, let's just say, fire alarms. Now, you have 4 different situations. No fire and no alarm. That's good. You have another situation. You have a fire and the alarm sounds. That's also good. You have another situation. The alarm sounds, but there's no fire. Annoying, but still okay. And then the last one, which is there's a fire and the alarm does not sound. That's very bad. Okay, 4 different situations for this. Now, they give you some percentages. If we look at it, let's see. So we got a false alarm, right? A false alarm 3% of the time. And then in approximately 0.5, that's not 50%, that's 0.5%, in which, let's see, actual incidents and the alarm, the system fails to sound an alarm. Okay, that's the worst case scenario. And then they also say that basically about 0.1% of their clients actually have a fire, an incident like that. Okay, so I'm going to try to figure out the 4 different percentages for the possibilities. How would I do that? Well, tree diagram? Yes, let's try that. Let's go with the tree diagram. So there's a 0.1% right here that they'll have an incident. So that's going to be, as a probability, 0.001, which means that the fact that they have no fire is 0.999. All right, so now let's look at the next thing. So here's this very bad situation. There's a fire and there's no alarm. Okay, so how often does that happen? They said 0.5% of the time. Okay. Which means that we would subtract that from 1 and we say, okay, that's the probability that there's a fire and the alarm sounds. So we subtract this from 1 and that gives us this right there. Okay, not too bad. Now we're going to look at what if there's no fire and there's an alarm. Okay, so, whoops, alarm. Okay, so that would be a false alarm, right? So what do we say? 3% for a false alarm? I think that's what it was. Yes, so that turns out to be 0.03, which, of course, the other one is going to be 0.97. So this is good over here. No fire, no alarm. So that's going to be a big, so see, multiply those 2, no fire, no alarm. That's for the majority of the people. Okay, but what's the question again? Suppose a client is selected at random. What is the probability that an alarm will sound at his premises? Well, what are the 2 places where an alarm sounds? Well, it's this branch, right? And this branch. So I would multiply these 2 things together to get this result. And I would multiply these 2 things together to get this result. And what is that result? So when you add these 2 together, you should get a result of approximately 0.0396. 0.0396. Oh, whoops. That's wrong. 0.03096. Dang it. Let me write that over again. 0.03096. So approximately, what do we have? So right there, that's our answer. If we get a person at random, approximately a 3% chance, 3.1% chance that they have an alarm go off. Okay, let's go to letter B. So on letter B, suppose the alarm is sounded at the client's premises. What is the probability that there was no break-in, smoke, or fire incident? Okay, so provided that an alarm went off, which we figured out right here, that's the probability that alarm goes off. What's the probability that there's no incident? That's right there. So this is how we would figure this out. And there it is. Given that an alarm went off, so we got to start with this. This is the probability that there was actually no fire. Okay, so this happened. The alarm went off. This is the probability that there's no fire. And what is the answer to that? And there's your answer, right there. Okay. Now, I'm not going to do number 6. I want you guys to read it and at least look at the information and think about it. And then when we come to class tomorrow, have some ideas. Here's the deal with number 6. It's going to be a question that you haven't seen before. It's outside the scope of the course, but you have a lot of tools to say something about what's going on. This 6th question is worth 1/8 of the points of the exam. So do not leave it blank. Read it first before you do any of the other free responses, and then think about it as you're doing the rest of the test. Anyway, we'll talk about it tomorrow, and have a nice night. Bye.